Properties of proportions. This is pretty straightforward. And again, as a review of algebra, we can do all sorts of things with our proportions. I can switch them around. If A over B equals C over D, then B over A equals D over C. I can flip both the fractions. Now, it doesn't mean that the new proportion is the same as the old one. That's a common misperception. I can say I have 3 over 6 equals 1/2. That's fine. Okay, that's a true proportion. Everybody agrees with that. If I flip it, I still have a true proportion. However, do not imagine that the ratios here equal the ratios here. The proportion is still true. The values of each ratio, however, have changed, haven't they? Okay. I can also flip along a diagonal. Oh, actually, 1 over 3, excuse me. Okay. I can flip along the diagonal. I can take those two numbers and flip them. And again, I still have a true proportion, but it's no longer equal to the original proportion. The values of the ratios have changed, but I still have a true proportion. So these rules of proportions give us true proportions, but they do change the values of the individual ratios in doing so. I could flip things along either diagonal. I could flip an entire, both entire fractions. I can do whatever I need to do with proportions. These are the properties of proportions. The one that's always tricky is this one. If A over B equals C over D, then A plus B over B equals C plus D over D. That's the tricky one. No, but you can when I put it online. All right, that's the one that gets a little tricky, and let me expand on that idea a little bit. It's A over B equals C over D. What we're going to do essentially is going to add 1 to each one of those ratios. So if that's true, then A over B plus 1 equals C over D plus 1, right? Because I can add 1 to both sides of an equation, it's still true. But I have to have a common denominator in order to add. So that's A over B plus B over B, because B over B is 1, equals C over D plus, it's not going to be B over B, it's going to be D over D on this side, isn't it? Because that's the common denominator on that side. So I get A plus B over B equals C plus D over D. That's where that proportion comes from. And we do see that in some examples. You will get some examples and be expected to do that. You'll be given like 3 over x equals 5/7. So what over x equals 12/7? And what you have to recognize is, what did I do here? 12/7 is 5/7 plus 7/7. So 3 over x, I'm going to have, since I add 7/7 here, I'm going to have to add what on this side? Well, not 7, x over x, right? I'm going to have to add 1. So this is going to be 3 plus x over x. So you'll see that in some of your problems where you have to identify properties of proportions. That'll be what's going on there. So you will run into this stuff now and then. Oh, joy. And those are our properties, and that's kind of how we're going to see them applied. And quite frankly, a lot of your homework today is going to look like things like, you have plenty of problems that are going to say, okay, if x over y equals 7 over b, then, and they'll give you something. X over 7 equals what? Well, what did I do? The x stayed put, the 7 flipped down up here. So if the 7 flips down over here, where does y have to go? Up top over here, we swap those two. So that would be y over b. Right? Or we could say then y over x equals, well, what I do, I flip that one, so I better flip that one. b over 7. All right? So a lot of it's going to be manipulating and rewriting the proportions using their properties. That's a lot of what we're talking about. This page can go out of the notes, actually. So, delete that page. Delete that page. That page. Here we go. Using proportions in geometry. Now that we have proportions, we need to start using them. And what you'll be what you'll be given today is you'll actually be given the proportions. You won't be asked to figure them out on your own yet. That's more in the next unit, as we start, or the next portion of this unit F, is you have to figure out your own proportions. Today, what they pretty much do is they tell you the proportion. They'll give you this: AB over XZ equals BC over ZY. All right. Then they'll give you some lengths. AB is 8. BC is 4. XZ is 12. And ZY is question mark. Oh, there's my question mark right there. Gee, how are we going to do it? Simplest thing to do, what I'm going to want you to do, because again, it's not about the answer, it's about how you get to the answer, is I'm going to want you to set up and show me the proportion that is there by substituting these values in. So I'm going to want to see as a solution 8 over 4 equals, AB over XZ, that'd be 8 over 12. Sorry. 8 over 12 equals BC over XY, 4 over X. Or 4 over question mark, or whatever you want to call it, N. I might not want to use X because X is already used as a point here, so I'll call that N. And then set it up, 8N equals 24. Okay? Did I set something up wrong? Should be 6. 48, that's what I did wrong. I multiplied wrong. I knew I did something wrong. So 8N equals 48 divided by 8, N equals 6. But again, if all you write down is this, I'm not going to give you the points. I want to see how you get there. I want to see you set up and solve the proportion. Because that's so much about what we're working on in these first two sections here, is how do you set up and solve the proportion. And on the quiz, if I give you a problem like this in the quiz, if you give me N equals 6, 3-point problem, I'll give you 1. The other 2 points are going to be for setting it up, showing me how it's done. Solution's only worth 1 out of the 3 points. The other 2 points are for how you do it. So problems like that, again, it's set up for you. You just have to plug the numbers in the right spots. Set up and solve the proportion. Another application of this is scale drawing. So it says in an actual Alfa Romeo race car, the distance between the wheels is 81 inches. Use the scale drawing below to find the actual overall length of the car. So distance between the wheels in an actual race car is 81 inches. How far is the distance between the wheels in our drawing? Well, we'll have to measure that. So I've got my ruler, and it looks like dead on 3 inches. Center to center on the wheels is 3 inches. Okay? So that's the actual over the picture. What's the actual length of the car if this is a true scale drawing? Well, we have to measure it. 5, and then I'm going to have to do a little bit extra down here because my ruler doesn't quite fit. So it's 5 1/4 inches. Okay? So it's X over 5 1/4. And now we're going to have to cross multiply, aren't we? We're going to have to set up a proportion, and we're going to have to do a cross multiplying to solve. Now that's going to be a little bit more, 81 times 5 1/4. It's 425 1/4. We have to divide by 3. And I get 141 3/4. So the actual length of a real race car of that style, if that's a scale drawing, is 141 3/4 inches. If I actually had an Alfa Romeo race car, then we could actually check it, yes, but no. Yeah, not going to. Oh, yeah, I'm sure I could find enough of those around here, but it's not necessary at this point. So those are the types of problems that we're going to be seeing today. We're going to be setting up and solving proportions. We're going to be using properties of proportions. We're going to be doing scale drawing, or looking at scale drawings to actually set things up. Now, you usually are not actually going to have to measure. For problems 25 and 26, you might have to use a ruler. And I'm not sure if I even assigned those. So let's take a look real quick. Oh, no, that's right. We're doing a worksheet today, so that's not an issue. The other part of the worksheet that we're going to have today is going to be review problems from Section 1. And tomorrow is a full review worksheet, and then we're taking that quiz on Monday. So make sure that you are, Jillian, don't leave until you get one of these. Get a worksheet. It's pretty straightforward. That's what we're doing. There's no measuring on here that's necessary. But one worksheet, both sides, in preparation. And tomorrow's review, Wednesday's benchmark, Thursday and Friday, a little bit of new stuff. Kind of watching that storm on Thursday to see if that's going to ice us out or something. It's fine. We'll get our quiz in on Wednesday no matter what, so we're good to go.